Hi friends, today we'll start with some problems based on kinematics of particles, and in that one rectilinear motion. Rectilinear motion means a straight line motion. When particle moves along a straight line, motion is called as straight line motion. Problem is based on rectilinear motion. Let's see what is given in problem. A particle starts moving along a straight line with initial velocity of 20 meters per second from origin under the uniform acceleration minus 2 meter per second square. That means acceleration is negative. That means velocity of particle will reduce. Determine number 1 velocity, displacement and distance covered at 6 seconds. Second part of problem is what? How long does the particle move in the same direction? What are its velocity, displacement and distance covered then? Is the second part. Third part of problem, the velocity, displacement and distance covered at 16 seconds. Number 4, the time required to come back to origin and velocity, displacement, distance covered at that time. As particle starts moving along a straight line from origin, now if we will represent, say this point as origin, particle starts, we will assume it moves in rightward direction with initial velocity given in problem u equal to 20 meters per second. This point is origin, coordinates 0, 0. Motion is a straight line motion. That means particle moves in rightward direction. As it is given, particle starts moving along a straight line with initial velocity 20 meters per second from origin under uniform acceleration minus 2 meters per second square. That means A equal to minus 2 meters per second square. Initial velocity positive, but acceleration is negative. When acceleration is negative, definitely velocity of particle will reduce. As it reduces and it becomes 0, then particle moves in reverse direction or particle changes its direction of motion. It means at this location, when particle changes its direction of motion, we have to identify what is the time instant here. Without time instant, solution is not possible. Already as we have discussed, when particle moves along a straight line, displacement and distance travelled remains same if particle continues in same direction of motion. But if particle reverses its direction of motion, displacement and distance travelled are different. Therefore, we will find out what is the time instant. Once we will get this time instant, particle moves in leftward direction and continues its motion in leftward direction. When particle reverses its direction of motion, its velocity must be 0. Using equation v equal to u plus at, you know velocity is 0, v is 0, u 20 plus acceleration a is minus 2 into t. Now if we will calculate, this one becomes what? 20 divided by 2 minus minus, both gets cancelled. What value of t we will get here is what? 10 seconds. What it represents? If particle moves in rightward direction for 10 seconds, then its velocity becomes 0 because we equated velocity to 0. And once it changes its direction of motion, particle continues its motion in leftward direction. That means from 0 to 10 seconds, displacement and distance travelled are same. And from this location, when it moves in leftward direction, in next time instances, displacement and distance traveled are different. Now what is asked in problem? Number 1, velocity, displacement and distance covered at 6 seconds. Now as this time instant you are getting as a 10 second, at 6 second if you want to find out, displacement and distance traveled are same. Therefore, at 6 second, first part of problem, at t equal to 6 second, when t is 6 second, first we will find out using our simple equation v equal to u plus at. V is final velocity, u is initial velocity, a is acceleration. What is given in problem is a time instant 6 seconds, acceleration is a 2, that is negative, and initial velocity is 20. That means we will get 20 plus this acceleration is minus 2, we will substitute here minus 2, and time is what? 6 seconds. That means velocity what you are getting here at 6 seconds, you may add here suffix as 6, it indicates velocity at 6 seconds. Now what answer comes out to be what? 20 minus 12, that means 20 minus 12 means comes out to be 8 meters per second. Answer positive, that means direction rightward. This is first answer of problem. Once we will get velocity at 6 seconds, next part what you have to find out is displacement and distance travelled. That means from this point O, coordinate 0, 0, t is 0, at 6 seconds, t equal to 6 seconds, say this location is a point A. Now we will find out what? At t equal to 6 seconds, what is the position? That means what is here x value? Y will get 0 because motion is along x axis. How will get position x? Using simple equation, x equal to ut plus half at square. Now if we will substitute your values, u is given as what? 20 meters per second, time t is what? 6 plus half, acceleration minus 2, and time is what? 6 seconds. Using this one, this answer comes out to be this one what we are getting, say 120, this one is negative term minus, and this one 2 cancel, what will get here? 36. That means what position you are getting x, this is also at 6 seconds, you may add here suffix 6 seconds, so you will get 84 meters. This is a position at t equal to 6 seconds. Displacement if you want to find out, it is always final position minus initial position. You know here final position is A, initial position is O. Can you write this one? X A minus X O. X A is 84 minus X O means coordinates at origin 0. That means displacement is 84 meters. Up to 6 seconds, displacement and distance travelled are same because particle moves in same direction of motion. Therefore, distance travelled equal to 84 meters. That means this is the first part of problem. In first part, what you are getting? Velocity at 6 seconds, 8 meters per second. Next, we are getting position at 6 seconds is 84 meter. Displacement, final position minus initial position comes out to be 84. particle continues in same direction of motion, therefore displacement and distance traveled are same. What is the second part of problem? Second part of problem is how long does the particle move in the same direction of motion. Already we have calculated at t equal to 10 seconds, velocity of particle is 0. That means what it represents, particle continues in its same direction for 10 seconds. This one is the first answer. Next we have to find out what is its velocity. The velocity is 0. Displacement and distance travelled by particle. To find the displacement and distance travelled, we will find out what is the position at t equal to 10 seconds. At t equal to 10 seconds, what is position at 10 seconds? That means using equation x equal to ut plus half at square, will substitute your value of initial velocity, time instant, acceleration, you will get position at 10 seconds. We will write this position with suffix 10. U is given as what? 20. Time is 10 seconds plus half. A is minus 2. Time is 10. It's square. This one comes out to be 200 minus 2 gets cancelled. What will get? 10 square means 100. That means final position at 10 seconds comes out to be 100 meters. Ex10. Displacement is always a final position minus initial position. Displacement, final position is at 10 seconds, x10. Initial position is origin minus x0. What we will get here is 100 minus 0, answer is 100 meters. Up to 10 seconds, particle continues its motion in same direction, therefore displacement and distance travelled are same up to 10 seconds. That means at 10 seconds, distance travelled is same as that of displacement. Distance travelled equal to 100 meters. Third part of problem, the velocity, displacement and distance travelled at t equal to 16 seconds. Number 3, at t equal to 16 seconds. What you have to find out? Its velocity, displacement and distance travelled. How will find out velocity of particle? Using same relation, v equal to u plus a into t. Initial velocity is given 20, acceleration is given minus 2, time is given 16 seconds. That means velocity at the 16 seconds, we will write with suffix 16, comes out to be 20 minus 32, that means minus 12 meters per second. Negative sign represents what? Particle moves in leftward direction, 12 meters per second leftward. This is your first answer, velocity at t equal to 16 seconds. Next, find out the next part. What is the next part of problem? Find displacement and distance covered at 16 seconds. That means position at 16 seconds is important. x16 using relation ut plus half at square We'll substitute initial velocity as 20, time instant 16 seconds, acceleration -2. Answer comes out to be, this one is 320 minus 16 square, 320 minus 16 square. Okay, this one answer, if you will calculate using calculator, position at 16 second is 64 meters. Now from 0 to 16 second, at time t equal to 16 second, displacement and distance travelled are different. Let us represent a path here. Origin 0 0, particle moves in rightward direction, then it moves in leftward direction. Here time instant is 10 second. Here position is 64, that means position is somewhere here. This time is what? 16 second. Now as a particle initially moves in rightward direction, then it moves in again in leftward direction, this 0 to 16 second time interval will divide in two parts, 0 to 10 second and 10 to 16 second. We'll find out displacement in each time interval independently and then we'll add. You know position at 10 second is 100 meters. You know position at 16 second is 64 meters. That means displacement equal to final position at 16 second, we'll write x16 minus initial position 0. Final position at 16 second is 64 meters, initial 0. That means displacement comes out to be 64 meter. Distance covered, if you want to find out, we'll divide given time interval from 0 to 16 second in two parts and we'll add displacement in both the time interval, say number 1, plus displacement in second time interval, say number 2. First means 0 to 10 second, second time interval is 10 to 16 second. How will write this displacement? Delta x in first time interval, again final position minus initial position. Final position means at t equal to 10 second, x 10 minus x 0. Second time interval, we will write this one final x 16 minus initial position means at 10 seconds, x 10. At 10 second position is 100 meter, at 0 second 0, plus at 16 second position we calculated 64 meters minus position at 10 second is 100 meters, 100 minus 0, 100, plus 64 minus 100 minus 36, mod sign we will get positive value. Answer comes out to be 136 meters. This is distance travelled. Or in previous slide, just see 0 to 10 second, here coordinates at this position 100, at this position it is 64 meters. That means this distance is 100, this is 64, remaining becomes 36. That means 100 plus 36, final answer 100 plus 36, 136 meters. Next part of problem, the time required to come back to origin and velocity, displacement and distance covered at that time. Time required to come back to origin means at same location. That means particle moves from O in rightward direction. Here you know now time is what? 10 seconds. Again when it comes here, how to find out? So here position is origin, that means 0, 0. To find out time required, fourth part, particle starts from this location, moves in rightward direction, it moves like this, reverses its direction of motion, finally comes to origin. That means here x value is 0, coordinates 0, 0, moves in rightward direction and come back to origin. That means here again final position is 0. We will assume here what time instant is say t. Therefore, if you want to find out how much time it takes to reach to again this position means origin, you know x0. If we will use relation x equal to ut plus half at square, final position at this time instant is 0, initial velocity given 20, time unknown plus half, acceleration minus 2 into t square. Using this one, if time t will find out, so t comes out to be 20 seconds. Use calculator to calculate this value. That means particle come back to origin at t equal to 20 seconds. You have to find out what is velocity, displacement and distance travelled at this time instant. At t equal to 20 seconds, velocity if you want to find out, use equation u plus at, initial velocity 20 plus acceleration minus 2 into time is 20. Velocity comes out to be this one 20 minus 40 means minus 20 meters per second. Negative sign represents what? Particle moves in leftward direction. We will add here direction 20 meters per second leftward. This one is the first answer. Now to find out displacement. Displacement is final position minus initial position. You know final position is origin, initial position is again origin. That means displacement final position minus initial position. Final position is 0, initial position is 0, displacement is 0. But during motion, particle changes its direction of motion. To find distance travelled, 0 to 20 second will divide in two parts, 0 to 10 second and next time interval 10 to 20 second. 0 to 20 second will divide as 0 to 10 and 10 to 20 second. We will find out displacement in this time interval. We will find out displacement in next time interval. We will add both the displacement without considering their sign. That means distance travelled equal to mod of delta x1 plus mod of delta x2. Delta x1 means displacement in first time interval 0 to 10 second, can be written as x10 minus x0 plus second time interval is 10 to 20 second, x20 final minus initial x10. x20, x10 minus x20, if we substitute values, x10 is 100, x0 means 0, x20 is 0, x10 is again 100. We'll substitute these values in this equation. 100 minus 0 plus second part x 20 minus x10, x20 is again 0 minus x10 is 100. Using mod sign, this one positive, second part also becomes positive. Distance travelled becomes 200 meters. Now if we represent graphically as we have done, you know this one is 100 meters. Easily you will understand, particle starts from this location, moves in rightward direction 100 meters, again moves in leftward direction, again 100, 100 plus 100, final answer is what? 200 meters is the distance travelled when particle passes through origin. This one rectilinear motion, but straight line motion, and different time instances were calculated position, then velocity, what is displacement, what is distance travelled. Thank you.